So now I'm going to demonstrate for the running of the single node for the MapReduce. So first, this command process the input data in the merge sorts input small, which is the small dataset for the merge sorts using the mapper script, and then send the intermediate data to the reducer script. So the reducer script will further process and aggregates the data to produce the final result, which shows at here, which is the execution time for the mapper and reducer. Then we can proceed with the second dataset, which is the big dataset for the merge sorts, and also we just click enter. So this dataset may require some time to process because the dataset is very big, which have around 10 million of the numbers in it. So here shows the execution time for the mapper and also the reducer. Alternative, we can choose to run the MapReduce on the Hadoop. So this command processes the large input file, which is the big dataset of the merge source. So the mapper script will then split the data into smaller units, while the reducer will process these smaller units to produce a final output. So the processed result is then stored in the specified output directory. And from here, we can then call the result. So here shows the execution time for the mapper and the reducer. Then we can proceed with the same command for running on the Hadoop for the small dataset of the merge sort. So after we running, we can then just call for the output. So here shows the execution time for the mapper and the reducer. Next, I'm going to demonstrate on running for the MPI code. So first, we can see that this code is for one processor of running for the small dataset of the merge sorts. And here shows the result. And then we can proceed with 2 processors. Also, we can proceed with 3 processors. And for the last one, we can then proceed with the 4 processor. So from here, we can see that as the number of the MPI process increases, the execution time may rise due to the overhead of launching, coordinating, and synchronizing the processes, so which can outweigh the benefit of parallelizing a small workload. We can then execute the MPI code for the large dataset. So for this command, it shows we can run for 1 processor. So the execution time is around 39 seconds, and we can then proceed with running for 2 processor for the big dataset. So here shows the execution time is around 26 seconds, and we can then proceed with 3 number of processor for running. And here shows the execution time is around 23 seconds, and the last one we can then proceed with 4 number of the processor. And we can see that the execution time is around 27 seconds. This means that for large dataset, when the number of the processor increases, the execution time is reduced.
Hi doctor, so I'll now show how to run NPM on multiple nodes. So in order to run it, we'll need to install Docker and also Kubernetes. So I'll now talk about the setup of Docker first. So we'll need to add a GPG key. And next, we'll have to set up the repository. Now we'll update the package list and install Docker CE. Okay, so we'll start and enable Docker. Enable it. Next, we can check our Docker installation on whether it's already successfully installed. So Docker version. And yep, our Docker is already successfully set up. Now I'll talk about the setup of Kubernetes. So we'll have to install micro-KS first. Next, we'll allow the firewall. Now we'll enable the DNS and also storage. Okay, so we can check whether our micro-KS has successfully run. And yes, it shows that the micro-KS is currently running. So in order to allow the slave node to join the master node, we'll have to create a token for the slave node. So using this token generated, we'll then paste this token into the slave node. So at the slave node, let's input the token generated. So the slave node has already joined the cluster. So back to the master node, let's check if the slave has successfully joined. So as you can see here, the slave node has already joined. So this is the slave node and this is our master node. So to run NPI on multiple nodes, let's go to the directory where all the files are stored first. So we'll have to create a Docker file. So this is the Docker file that I've already created beforehand. So in this Docker file, we'll install the required packages and also copy the NPI button script to the Docker container. Now we'll build the Docker image. Next, we'll push the image to Docker Hub. Next, we'll create the Kubernetes deployment YAML file. So this is the YAML file that I've created beforehand. So this is the Docker image just now, and also our merge sort input with a small data set. So we can also change the process. So I'll change the number of process from 3 to 2. Now we'll deploy the YAML file. So we can check the pod. So as you can see, our pod is already running. So we can get the result of the pod. And yep, this is the result of the MPI sort, merge sort. So this is the unsorted data and also the sorted data, and the execution, this is the execution time.
be demonstrating the installation and configuration required to run MapReduce program on multiple nodes. So at first, make sure that you have installed Ubuntu 24.04 from the official Ubuntu website here. Then, in the VirtualBox managers, create a new virtual machine. Select the IS4 image for using the Ubuntu that you have installed just now. Make sure to change the username and also the password and to configure the hardware. So here I'll be choosing 9000 MB and 3 CPUs and finish to create the new virtual machines. So here click enter to install the Ubuntu. So once you have followed the instructions and successfully installed Ubuntu on your virtual machines, you should configure the network in here. Then navigate to the network part, enable the adapter tool, attach it to the host-only adapter, and allow all permissions. Click on OK, and then start the virtual machines. So once you have started your master virtual machine, make sure to install the SSH using this command. Once the SSH has been installed successfully, install the PDSH using the same command. Now navigate to the bashrc file. From here you have to add in save and exit the file. Now you have to configure the SSH by creating a new key using this command. Then copy it to the authorized keys file. Now verify if the SSH configuration using this command. Input yes. Okay, now you have to install the Java using the command. Sudo apt install .jdk. Now you can verify whether Java has been installed successfully using this command. And as you can see, the Java has been installed successfully. Moving on to the Hadoop setup, download the Hadoop using this command line, which I have installed the Hadoop version 3.4.1. Once Hadoop is done downloaded, unzip the file. Now change the folder name. Then navigate to the Hadoop environment file. On the line of export Java home, uncomment that line and input this file, save and exit the file. Then change the directory to Hadoop directory. Edit the environment file. Add on this to the file. Save and exit. Then add on the user Hadoop user. Then configure the user permissions and add it to the group sudo. Now verify the master node IP address. So as you can see, the IP address for master node is 192.168.20.3. So for the slave node, I'll be adding 1 to the end, so it will be 192.168.20.4 for the slave node IP address. Now insert the network configuration in the host file. So this is the IP address for the master node, and the IP address for the slave node. Save and exit the file. Now shut down the master virtual machine. Then clone this, make a full clone of this virtual machine. Make sure that it is a full clone and select generate new MSD address for all network adapter and finish. Now once the slave node has been done clone, start it along with the master node. After 2 of the virtual machine is started, which as you can see, this is the master node, this is the slave node. So at the master node, edit the host name. So I'll be editing it to Hadoop master. Save and exit the file. Same goes for the slave node. Edit its host name. Save and exit the file. Now reboot both virtual machines. Now, as you can see, the host name has been updated. For the master node, it is how to master. As for the slave node, it is how to slave 1. So for both of the virtual machines, switch to the users, how to users. On the master node, create the SSH key using this command. Then copy it to all the users, including master and the slave node. Now this error shows that it could not connect to the slave node, and as you can see from the IP address of the slave node, it is 192.168.20.5, which is different from the one that we have keyed in just now. So let's navigate back to the host file and update the IP address for the slave node. Save and exit the file, then try and copy it to the slave node again. So now edit the call site.xml file. Save and exit the file. Then edit the HDFS.xml file. Save and exit. That's it. Then move on to the workflow and on the slave node, which is how to slave 1. Save and exit. Now copy the configuration of the master node to the slave node. Now run this two line of code. Start the graphics. Use the command JPS to check the resource initialized on all the virtual machines. So this is the master node, and this is the slave node. You can navigate to the browsers on this URL to see the slave node that is operational. Which, as you can see, slave 1 is operational. Now configure the yarn using this set of commands. On the slave node, edit the yarn site XML. Properties, save and edit. Now the master node start yarn. Now navigate to the browsers. On the URL, you could see all the active nodes. So as you can see, there is one active node right now. The Python has been installed on the virtual machine. It shows that the hard streaming is available on the virtual machines. Now download all the zip file, including the MapReduce Python program, as well as input text file from our GitHub. Then move the zip file, extract and move the zip file into the local directory using these commands, which move it to the users, hardware users, in the folder CST435 assignment. Next, create an input directory on the HDFS using this command, which I have already created last time, and upload both the dataset small and big dataset into the directory using two commands, which I also uploaded last time. The HDFS using this command. Which, as you can see, both the small dataset and big dataset have been uploaded into the HDFS. Now run these codes to run the MapReduce program using the small dataset. So this error shows that there is already output existed, which you can remove the previous output using this command. Then rerun the code again. To view the output, run this command. It shows that the output directory is this part -00000. So run this command. Now this is the output, including the unsorted and sorted data and the mapper and the reducer execution time. That is all for our code. Thank you.